Our next slammer is Miles Roberts, representing the Center for the Study of Evolution in Action. He's a student at Michigan State University. Over to you, Miles.
Have you ever seen a colorful array of apples at a store and wondered why they look and taste so differently from each other? Part of the answer is that each one was built from a unique blueprint. And those blueprints look like this. This is a model of a molecule called DNA. The real thing fits into the tiny cells of all living creatures, but this model is 60 million times larger than the real thing, so you can actually see it. Now, how could this weird structure act as a blueprint? Well, each little step in this structure acts like a different letter in the alphabet. Multiple letters together can form a word, and multiple words together can form an instruction to say, for example, give this apple green skin. But different apples obviously carry different instructions. Why is that? Well, whenever any life form reproduces, ask your parents if you want the details, they must copy their DNA and pass that copy on to their children. But during this process, sometimes cells may accidentally swap out, add, or delete letters from DNA. That can change the meaning of DNA's instructions, and we call those errors mutations. On the surface, mutations might sound bad. However, most mutations actually don't alter the instructions in DNA. And those that do sometimes give life forms cool new traits, such as green skin. So for decades, scientists like me have been trying to find and understand the interesting mutations in DNA. However, that's not easy because the instructions in DNA are not logically organized. They're organized much like how a pile of jumbled up puzzle pieces may be organized. In other words, there's no neatly ordered recipe that you can read when you just look at DNA. But there is hope. One way we can learn why life forms like apples often differ from each other is to use, wait for it, math to look for mutations that usually occur in individuals with some cool quality. A particular mutation, for example, only occurs in the DNA of apples with green skin. That might be because that mutation causes or contributes to green skin. We call this approach a genome-wide association study, or GWAS for short. Genome here just refers to the collection of all the DNA in a cell. And this approach is so cool, its name can be rearranged to spell swag. Better yet, this approach is not just limited to apples. Scientists are also using it to find mutations that cause dogs to be incredibly adorable, or the mutations that cause tomatoes to generally taste disgusting and like styrofoam. But overall, this approach has taught us that mutations underlie much of the incredible diversity we see in life. In a very real way, these quote-unquote errors in DNA are part of what make all life forms, from apples to us, unique. Thank you.